Hi students, so now we will be solving this particular problem based on the previous concept only that we did, like substitution, okay, the concept of substitution. This is a fairly easy problem, but the only thing is the calculation is a bit lengthy, okay. Initially it is a bit lengthy because now you are solving problems as a beginner, but once you solve more and more concepts, this problem will be very crisp and very easy, okay. So first what we will do here is we have sine 2x, right? Integration of sine 2x divided by a plus b cos x whole square dx. All right. So first what we will be doing here is, first we will say, let's take this part as t, okay, because roughly you can see that after taking the derivative we will get a sin x from here, so which has a bit of relevance, right, which finds a bit of relevance here because we have sin 2x in the numerator, though completely we are not getting it as of now. But let's see, let's take this part as t. So when we take the derivative, okay, what we get here is derivative of a is 0, and of this part is b will stay as it is because it's a constant, and cos of x is minus of sin x, right, and dx equal to dt, okay. So if I do the complete thing here, then in place of sin x dx we will be getting a minus 1 by b dt. Now you might ask that in the numerator we have sine 2x, right, and here we have sine x dx, and in the numerator we have sine 2x dx. So what we will be doing now, before going there, first we have to do a small calculation here. That is, you can see that here a plus b cos x equals to t. So from here, if I want to separate cos x, how will I do that? I'll take t minus a, this a will come here, so it will become t minus a divided by b, right? So cos x can be written as t minus a by b, okay. In terms of t, I am trying to express cos x because cos x is in terms of x and I want to express it in terms of t. Why do I want to do so? You will understand, okay. Once I break this sine to x, I'll be getting 2 sin x cos x, right. So when I replace the other terms, the only term that will be left is cos x. So then I have to replace cos x by this particular format. Now let me proceed with the problem so that you can understand it better, okay. So next, what am I up to? Next I'll be writing this particular thing, okay. In place of sine 2x, I can write 2 sine x cos x. Can I write or not? And in the denominator, I will have a plus b cos x whole square dx, right? Now my only work is to keep doing manipulations till the end. There is no other thing that is left in this problem. So first I'll be taking 2 outside of the integration sign because it is a constant. And what I'll be doing is, in place of sine x, okay, in place of sine x dx, I'll be replacing it with minus 1 by b dt. In place of sine x dx, I'll be replacing with that particular thing. Minus 1 by b into dt. Okay, I'll write this at the end because dt is present here, so I cannot write it at the first. First I'll write cos x, okay. First I'll write cos x. Cos x is t minus a by b, so I'll replace cos x first. 2 I have taken outside, so I'll be replacing cos x first, t minus a by b. Alright, and then I'll be writing sin x. I hope you understood why I wrote sin x later. I wrote it later from here. Sin x dx is this one. I wrote sin x part later because here we have dt, so format wise we have to write dt at the last, right? That is why I did it. And one more thing here, this one needs a replacement. Okay, so this will become t square because we took a plus b cos x as t, right? So finally we have done it. Now I'll be doing a bit more manipulation. You can see b square here, right? That will come outside of this. Now I hope you understand that from here, from this particular step, what we will be getting. I hope that doesn't stand as a confusion for any one of you. This is some basic mathematics that you have done when you were really young. Okay, this is what we get, right? So this b square we will take outside, okay, and then we will be left with a very simple form. All right, let's see what that form is. Now what we will be doing here is we will be taking b square outside. Also we will be taking this minus sign outside, okay, and then what we will be left with is a t minus a in the numerator and a t square in the denominator, right? And we have to integrate this, right? So this is the integration that we have to do now. Now in order to do this integration, first we will separate, okay, for simplification of this entire thing we will just separate the terms. So t by t square becomes 1 by t and a by t square becomes a t to the power minus 2 into dt. Now what we will be doing here, this will be as it is, and here 1 by t integration is dt integration is nothing but what? Log of mod t. We have done this numerous times, so I don't think there is any problem in figuring this out here. Also a will be constant as it is, and the integration of t to the power minus 2 is nothing but t to the power minus 2 plus 1 divided by minus 2 plus 1, right, plus c. All right, at the end what we get, minus 2 by b square, we will have it as it is, and in the bracket what we will be having is log of a plus b cos x. I hope you are understanding why I did it, because I already told you in the previous two videos that when we will be taking a variable, it is our responsibility to actually replace the variable as well at the end, right? So this is exactly what I have done here. And finally here what we will be getting, this minus minus will become plus, okay, and we will be having a plus here, and then a will remain as it is, and t inverse, right? What is the meaning of t inverse here? Nothing but 1 by t, right? So what is the value of t? A plus b cos x, as simple as that, right? So this is our final answer. I hope this problem is clear to you. As I already said, this problem is no rocket science, but the only thing is that you have to do a couple of manipulations, and this ends the problem, okay? We will be doing one more problem, which is actually you can say from it is a board exam problem, okay? I'll be showing you at least halfway through. I'll take you. After that I think you can do, but still I'll be solving it in case you have any issues. All right, so this is the problem that has been asked in one of the board exams, okay? Integration is a very tricky chapter, you know. It just makes you feel that it is too hard. What is it? It is too complicated. But that one trick, if you can just break it, you know, if you can crack that one nut, then the entire problem gets solved, mostly, at least in the medium level and sometimes even in the advanced level, okay? So this is the particular problem. All right, this might look huge to you, but as it is not. The first thing here that you need to understand is that if you take log of tan x by 2 as a t, okay, then more than half of the problem gets solved. Why? because once you take this derivative, what you get is, tell me how to take the derivative of log of tan x by 2. First, we have to take the derivative of log, which will give us nothing but 1 by tan x by 2. I hope you know the derivative of log t or log x. Log x derivative is nothing but 1 by x, okay? So we have x as tan x by 2 here. This is why I wrote 1 by tan x by 2. I hope this requires no further explanation. Also, what is the derivative of tan x by 2? The derivative of tan x by 2 is nothing but sec square x by 2 dx equal to dt. Is it correct? No, it is not, because who will take that half? Right? That half needs to be multiplied. These are all the rules and regulations that you have in the chapter of differentiation and derivatives, okay? This must be known to you in order to solve these very basic fundamental problems, okay? So now that we have arrived here, what else can we do? We can do a small thing here, that is, this will become cos of x by 2 divided by sine of x by 2, and this will become 1 by cos square x by 2 dot half dx equal to dt. I hope you understood what I did here. 1 by tan x by 2. The tan x by 2 is nothing but sin x by 2 divided by cos x by 2, but there is the reciprocal of tan, which becomes cos by sine. If tan is sine by cos, then reciprocal of tan will be cos by sine. As simple as that. And we know that sec is nothing but 1 by cos. That is what I have done here. Now we will simply break it. 1 cos by x by 2 and 1 cos x by 2 here gets cancelled. So in the denominator, we are left with 1 by 2 sin x by 2 cos x by 2 dx equal to dt. So finally, can you see that we have a direct trigonometric formula to be applied here, that is nothing but 1 by sin x dx equal to dt, right? And what is 1 by sin x dx? Nothing but cosec x dx dt. Understand? We got the numerator here, right? So when we take log of tan x by 2 as t, we get cosec x dx as dt. It's as simple as that. Alright. So just replace the particular format. Log tan x by 2, this thing is nothing but 1 by t. And what is cosec x dx? Nothing but dt. So ultimately we get log of mod t plus c. Integration of 1 by t dt is nothing but log of mod t plus c, right? And at the end we have to replace, right? Please don't forget to replace. Your entire answer will go wrong if you don't do that, because I don't know, some boards are very strict with all of these things. So they essentially cut off your marks, okay? Entire marks they take away. This has happened actually. So log of log tan x by 2 plus c. Alright. If you don't replace it, then even if they don't take away the entire mark, but they will take away maximum of the mark, okay? Because t is something which you have considered here for your simplicity. So it is important for you to, replace it once the entire calculation is over. So the final answer that we have got here is log of mod log of tan x by 2 plus c. Alright. So the two problems that I did give you here is not very important, but it definitely built a foundation, okay, which will actually help you in solving more and more kinds of problems in the near future. The kinds of problems that I am solving now, sometimes they are not directly asked in the board exams, but the concepts that we exactly use in these problems, that is what is required in the not the board exams, in the entrance exams, okay? We usually, such kind of very easy fundamental problems don't come in the entrance exams, but these exact fundamentals are what is actually used to make difficult questions in the entrance exams. Okay, so even if you think that this is something which is not needed, please don't do that. Go through all the steps now, and if you're a beginner, then I'd even ask you to actually break all the steps and do it, because initially if you apply too much of shortcuts, there are chances that you might end up in a lot of silly mistakes, and I don't want any one of you to go through that difficult phase. Okay, there is a high chance that in integration, even if you know the problem, even if you solve it till the end, you won't get the answer because of silly mistakes. So try not to crisp problems right at this point. If you are starting your 12th grade, try to take it bit by bit. Then slowly, when you have a grip over the entire subject, then over the entire chapter, then you may skip steps and do whatever you want. Okay, because point is to actually get the answer. All right, so now let's move on to the next video.